Hi, I'm Roxanne Martin, and today I'm going to be teaching you guys about inverse derivatives, and this is for Mr. Farrar's Calc AB class, period 3. So, an inverse derivative is just the derivative of an inverse function, and what's important here is the notation, so it's going to be d dx, or the derivative with respect to x, of the inverse of x. So, f with that -1 superscript, the inverse of x. And this is something we're going to see a lot, and sometimes it's going to be written in slightly different forms, but it's important to remember that this is the notation for an inverse derivative. Okay, so I'm sure you all know what the inverse of a function is, but I'm just going to review really quickly. So it's where the x and the y are flipped. So xy, the values that become yx. So if y equals 2x, what we would do is flip the x and the y. So x equals 2y. And then if we solve again for y, y equals 1/2 x. And that is the inverse of the function 2x. There is a formal and informal way of finding inverse derivatives, but I like the informal way better, so we're going to start with that. In this problem, we're going to say that the inverse of f of x is equal to g of x. This is something that we're going to see a lot, because it's a lot easier to write g of x than that funky looking notation. And also this way we can say find g prime of x, which is a much cleaner notation than having to say find prime of f of inverse of x. So also for this, since we're doing a general form, we're just going to say for all x's, so at x rather than at x equals a value. The way we're going to start is we're going to say that g prime of x is equal to blank, and that g prime of x is just code for g of x. So then we're going to find the blank that g of x is equal to, that unknown value. So going back to the original equation, and since it's its inverse, we know that f of whatever that blank value is equal to x. And since those blank values are the same, we can assign a variable to it. So we're going to call both of those z. Now, if we go back to the original f of x, we can find what z makes f of x equal to x, if that makes sense. So we're going to find that z value, and then find f prime, and then find f prime of z. So then, since f and g are inverses, if we reciprocate the f prime of z, which we're going to call s, g prime of x is just equal to 1 over s. And I like this way of doing it because it's easy and also it's procedural, so it's difficult to mess up on. Now we're going to find the general form of an inverse derivative using the formal procedure. We're going to go with the same thing as before, with that g of x is equal to the inverse of x. But now the first thing we're going to do is derive f prime of x. Let's remember that what we're trying to find is d over dx, so the derivative with respect to x, of g of x. So quickly, we're just going to rewrite that, and we're going to see that it's that d over dx of f of inverse of x that we saw at the beginning that I told you would reappear. So that notation reminds us that g of x is really just the inverse of f of x, so just 1 over f of x, which means that its derivative is just 1 over the derivative of f of x. I also want you to notice that out of this, we get the exact same thing. That 1 over f prime of x is the same as we got from the informal. So here's a relatively easy example problem where we're going to use the informal procedure. First, we're going to identify what it is we want to find, g prime of 2. And since that's code for g of 2, we're going to write that. And remembering that g and f are inverses, we're going to say that f of blank is equal to 2. So we're going to go back to the original equation, and from here it's pretty easy. We're going to know that f of 0 is equal to 2. And it's not really necessary to fill it in, but now we know that g of 2 is equal to 0. So now let's go to f prime. Well, next thing we want to find is f prime of 0. So let's get f prime, just easy power rule all the way down. So 4x cubed plus 9x squared plus 4x plus 12. Since we're finding f prime of 0, let's set that x equal to 0, so it's easy, just equal to 12. So f prime of 0 is equal to 12. And here we want to reciprocate, since we know that f and g are inverse functions. So reciprocating 12 gives us g prime of 2, which is equal to 1/12. For our next, a little more complicated example, we're going to use the formal procedure. So f prime of x is going to be equal to 1 over x squared times 2x plus 9x squared. That should be x squared. I'm going to fix it in a sec. There we go. Okay. So let's simplify that, and we're going to get 2 over x plus 9x squared, and then that's going to be equal to 2 plus 9x cubed all over x. So g prime of x is going to be 1 over that. So g prime of x is equal to 1 over 2 plus 9x cubed over x. And of course, which is equal to x over 2 plus 9x cubed. So now we want to substitute in that 1 for g prime of 1. So g prime of 1 is equal to 1 over 11. One thing that can be confusing is when to use the formal procedure and when to use the informal procedure. So I would say that the formal procedure is for more complex equations, and that the informal procedure is for less complex equations. When possible, I like to use the informal procedure because for me, it's just a lot faster. One common mistake is this, putting the same values for f and f inverse of x, and forgetting that their reciprocals, or the x's and y's, are flipped. So here, this should be f of blank is equal to 2, rather than the same thing as it is for f inverse of x. So here would be 0. But this is something that you really have to be careful of because it can mess up your entire procedure. Thanks for watching. And also, there's a practice problem worksheet available if you want a little bit of extra help or a little extra practice.